Welcome to Summarize Science. Today we are looking at a fascinating paper called AlphaTransit, which explores how AI can design city-scale bus routes. Designing a transit network is a massive puzzle where one small change can affect the whole city. Usually, planners don't know if a new route extension is truly helpful until the entire network is simulated. This is known as the transit route network design problem, and it is incredibly difficult to solve. Researchers developed a system called AlphaTransit to tackle this using advanced planning techniques. It combines a neural network with a strategy called Monte Carlo tree search. The neural network acts like an expert's intuition, suggesting which bus stop connections look promising. Meanwhile, the search part of the system looks ahead into the future to see how those choices play out. A key feature of AlphaTransit is that it doesn't need to run a slow traffic simulator at every single step. Instead, it uses its value network to predict the final quality of the completed transit map. This makes the design process much faster and more practical for large cities. They tested this system on a real-world map of Bloomington, Indiana. The system used census data and actual road layouts to ensure the simulations were realistic. In these tests, AlphaTransit significantly outperformed traditional reinforcement learning methods. It achieved a much higher service rate, meaning it could help more people get to where they need to go. The AI-designed routes also resulted in lower wait times for passengers. From an operator's perspective, the routes were more efficient, using fewer buses to serve more people. The researchers also looked at transfer rates, or how often passengers have to switch buses. They found that AlphaTransit creates a balanced trade-off between passenger convenience and operational costs. To see if it could work elsewhere, they even tested it on a different city, Laval, Quebec. Even without specific training on the Laval map, the AI's general strategies remained very effective. This suggests that the system learns universal principles of good transit design. Visual maps of the design show that AlphaTransit creates more targeted, logical paths than random or basic methods. By avoiding unnecessary overlaps, the AI ensures that resources aren't wasted. Let's recap the most important takeaways from this research. AlphaTransit uses a look-ahead mechanism to make better local decisions during the design phase. It successfully handles the complex, delayed feedback that usually makes urban planning so hard. The results show significant gains in service rates and bus utilization compared to older methods. In the future, this could be a vital tool for city agencies to improve public transport for millions of people. It could help make cities more accessible, especially for low-income workers who rely on buses. Automated planning like this allows for exploring thousands of possibilities that humans might never consider. This is a great example of how AI can solve real-world logistical problems to improve our daily lives. Thank you for watching this episode of Summarize Science.